We ended my last video with a pallet of ductwork parts ready to install and the plan for my layout in hand. Let me share the tips and tricks I learned during my install as we see how it all comes together, shall we? This video is sponsored by Oneida, who sent me the ductwork needed to make my ductwork design a reality and of course to show y'all how I did it. To get started, I unboxed all my parts from their very optimally packed boxes. Oneida nests the unconstructed pipes within each other and even nests smaller elbows inside of larger ones to make sure no amount of space within the box goes to waste. With my shop floor looking like the Tin Man met his untimely demise, I found myself a little nervous to put up the first piece. This was odd as that first piece didn't even require me to cut anything and thus was super undoable. But pushing past that fear of screwing something up, I found that that first piece really acts as a catalyst to your motivation and confidence, and from there you just can't wait to put up the next piece and then the next and the next to see your system unfold. Oneida supplies steel hanging strap for the ducting, which can work well for pretty much all situations, walls and ceilings, but I personally think that strapping looks the best in installations where your ceilings are much higher up than where your ducting is going to hang. What I think is a neater approach for lower ceilings like mine and wall installations are brackets to perfectly support the pipe. I made mine on the laser cutter, but you could easily make these on a bandsaw or with a jigsaw or even a 3D printer if you have one. I designed a variety of styles from J style to U style to O style, each in sizes ranging from 2-inch to 7-inch pipe sizes. I decided to prepare the entire bundle of bracket files as a free download on my website, so if you'd like to grab these for your own ductwork installation, check it out after the video. Don't worry, I'll remind you at the end. So with one of my 7-inch J-hooks prepared, I installed it on the wall and rested the piece that would be supported by it to measure the length of the pipe I needed to bridge the gap. Which brings me to my first tip. If you need to know how long a straight piece of pipe should be, install both pieces that it'll bridge first, if you can, then measure the distance between the two ends, adding about 1.5 inches on each end for the male and female ends to nest inside of each other. So if your measurement is 20 inches between the pipes, cut your pipe around 23 inches and it should fit perfectly once you've crimped one end and the nesting happens. Feel free to cut it a little on the longer side for your first few times, as you can always cut a little bit more of it off, but if you cut it too short, that's no bueno. But before you can cut the snap block ducting to size, you'll need to snap it together first. If you guess that's where it got its name, well, you get a gold star. I mentioned earlier that the pipes are sent nested together. This is made possible due to the fact that they have a seam along the length of the pipe that you need to close before cutting and installing. It's basically a channel lock system where the two halves are pressed together and when fully seated are kept together by the outward pressure from the pipe trying to lay flat, like it did when it was just a piece of sheet metal. That leads me to my next tip. You'll want to overextend the two ends into the circle that it will eventually form to get the snap lock started, and then work your way down the length of the pipe until it reaches the other end, where you'll likely hear an audible snap as the pressure in the channel stabilizes. Each straight section of pipe needs to be snap locked together like this before cutting and hanging. Once you're done snapping a section of pipe together, you may find you didn't have the ends perfectly aligned when you started, and so once locked together, your pipe has a little bit of an overhang on each end's rim. When this happens, I found it was best to stand the tube upright onto a firm surface like a concrete floor, then place a piece of scrap wood on the end of the pipe and gently pound it down with a hammer. It'd be difficult to hammer the wall of the pipe by itself without bending it over, so by using a piece of wood, you can reposition it down the length of the pipe by applying the force over the entire rim. The nice thing about this method is that once the rim is level, any additional pounding won't overextend it, it'll just stop. You can also use this trick for combining male and female ends. I found that some of the male fittings on the Ys were a bit of a tight fit, making it a bit difficult to install them into their matching female ends, especially while up in the air. By stacking them on top of each other down on the ground and making sure the rim of the male piece was at least started all the way around, you can use this piece of scrap wood to tap them into each other. Just be wary of overdoing it here, as forcing it too far in can make the snap block ducting unzip, requiring you to redo it. When you're working on assembling sections like this down on the ground, I recommend taping and screwing them together while you're at it, because otherwise they can come undone up in the air while you're trying to get it secured. I worked my way along the north wall of my shop, doing a majority of that run first. I initially wanted to save my taping and sealing for the end, but with some of the reducers I found that I had to screw and tape them together in order for them to stay level or in place for the next piece to be installed. The great part about my J-style hooks for the wall is that I could get the pipe level and in place and then just slide it under the pipe and screw it down. Super easy. Once I completed this run down to my joiner, I switched to the flexible ducting, securing it to both the reducer and the metal pipe with a quick release pipe clamp. After I was fully done with the north wall, I could set my sights on traversing across the room and doing the various branches we had planned up there. I did the first few elbows up to the ceiling while doing the north wall just to make sure I was placing the bottom Y in a good spot to get it up to the ceiling. These elbows rise and twist just enough to get me up to the ceiling without needing a short section of pipe in between them. And this is where my second style of bracket comes in, the U style. With it, I was able to position the pipe on the ceiling in the exact direction I wanted it to point, place a U bracket around it, and lock it in place with a few screws. As far as my shop lighting went, I got extremely lucky here. When Lisa and I talked through my design in our design consult, we acknowledged that there would be lights to work around, but I told her they could move if need be, thus we didn't take any particular strides to avoid them. Well, with some careful adjusting on my elbows and angling of the pipe that first shot across the ceiling, I was able to avoid the lights here entirely by going at a diagonal between them. This same fiddling and maneuvering came into play further down the run when I had to avoid the light on the way down to the table saw, and again when I needed to avoid the light on the way over to the miter saw station. In the end, I didn't have to move any of my lights, which was super nice. The trunk that traveled across the room had 3 main drops. 2 to the tools I just mentioned, the miter saw and the table saw, but then also to the center of the shop for a workbench I plan to build that will have some tools that flip out of the way when not in use, such as my planer and spindle sander. Per Lisa's suggestion in my last video, we also added a capped off portion here for future expansion. I'm presently considering getting a drum sander, in which case if I get it, I'll likely put it over by my laser cutter and I can extend my system to collect its dust when the time comes. Let's touch on some of the details of these various runs, starting with the miter saw station. I decided to extend my pipe about halfway down into the dust box, and I cut it on an angle to hopefully increase some of the horizontal air movement. This box is a little deep, so reaching in there to open a blast gate wouldn't be fun, so I decided to put the blast gate above the miter saw station, and then I cut myself a little reacher stick on the laser to grab the lip of the blast gate to open or close it. As for the miter saw box itself, following Jay Bates' thinking for my Jay Bates miter saw station seemed appropriate. As such, I'm not overly concerned with collecting every bit of dust that the miter saw produces. My primary goal, like Jay's, is just to have a constant negative draft into the box so that all the fine dust won't be all up in my face. The big stuff can accumulate in the back of the box and build up over time, where I'll occasionally make an offering to the dust gods. But to achieve this negative draft, I need to make sure that the enclosure was as airtight as possible. There were all sorts of seams and joints on the inside that the dust collector in theory could pull air from. Between the wall and the inside wall of the box, all the joints that made up the base that the saw sat on, etc. I'd previously used duct tape when I first built it, but it pretty quickly started peeling and thus lost its tackiness, so I decided to redo the seams with caulk. Luckily, I found that they make an almond colored caulk that pretty closely matches the bare wood of my miter saw station once dried. I applied this to every screw hole, every wood joint, etc. within the miter saw box so that any air needed for the collector would be forced to come from the front of the saw and hopefully would carry fine particulate from cuts along with it. Once I had it all ducted and vented, but before putting the saw back in, I wanted to see how strong the draft was with all the seams caulked. So I made some quick and dirty ribbon paper on my laser cutter and taped it up before powering up the collector and closing the other gates. The results were exactly what I'd hoped. A strong draft pulling the full weight of all the strips back into the dust box. The weight of individual fine particulates will weigh far less than the paper, so fine dust shouldn't be any trouble at all. Next, let's talk about the table saw. If you watched my last video where we came up with a plan, you'll know that my table saw and router table sit underneath my garage door that still needs to be able to open. I propose having the ductwork come back down under the height of the open garage door, going over top of the table saw and then straight down to the floor on the opposite side of the outfeed table. To achieve this, I created yet another bracket style, the O style. I'm not a big Star Wars guy, but this kind of looks like an advanced TIE fighter, no? This one wraps entirely around the pipe with some metal strapping locked into the joints that I could use to secure it to the ceiling before the pipe made its final descent below the garage door. Why not just use metal strapping alone? Well, metal on metal is prone to slipping at this steep angle, where by contrast, my bracket can firmly grasp it and hold it in place.
Firmly grasp it!
When I secured the strapping to the ceiling, I didn't do a very good job of making sure my O bracket was level, so it's kinda cockeyed, but that sort of fits the vibe of the TIE fighter anyway, right? Once my pipe was angled beneath the garage door, I jumped ahead to the opposite side of the outfeed table and worked on finishing the connections to the tools. It would be easiest to come back to bridge the gap, like I described earlier, once I knew both ends were finalized. I decided to use my outfeed table as yet another surface to mount one of my U brackets to add stability to this branch. I also played with the placement of the blast gates a little bit, trying to figure out where I wanted them. Intuitively, it would be nice to have them all above the table surface for ease of use. It's not very ergonomic to have to bend over to open and close blast gates. If my table saw was the only tool that connected below the surface of the table, I could have just done that. But my router table had connections both on top and below the table, meaning in order to have the Y and flex ducting not be in the way above the table, it was best just to have the Y and those two blast gates to be below the table height. I was perfectly okay with this, and it's not too much trouble to bend over a little. Plus, if I ever automate my blast gates, which knowing myself by now is basically inevitable, this will be even less of an issue. Once the ducting was installed on and below the outview table, I could bridge that gap above the table by measuring the exact size I needed. I realize I haven't shown you how to cut the ducting yet. Well, there's lots of ways to bake that cake. Here's how I found worked best for me. A jigsaw with a metal cutting blade gives a relatively clean cut, but getting that cut started on a round surface with a jigsaw is darn near impossible. You end up just punching the pipe with the dullest part of the blade. So my method for all the cuts was to get the cut started with a reciprocating saw at a very shallow angle until I just pierced the metal enough that the jigsaw blade could slip in, whereby the jigsaw could finish the job. I found keeping the jigsaw steady and slowly rotating the pipe beneath it also worked best. When measuring the placement of the cut line, I made sure to mark the line with a Sharpie in multiple spots around the pipe so I didn't stray while rotating the pipe. Also worth noting, whenever you're handling the bare edges of the ductwork, such as when closing the snap lock seams, but especially when dealing with freshly cut edges, please wear gloves to protect your hands, as edges can be sharp. If you have any burrs left from cutting, you can knock them down and smooth them with a metal file. While we're at the table saw, want to see how much dust was built up in my saw from using it without a dust collector for over a year since I got it? I knew it would be quite a bit, so I made sure to have my camera pointed on the translucent flex ducting when I turned the collector on with that gate open for the first time. Very satisfying. Last but not least, the final run of my system was also behind my miter saw station, running a 4-inch port over to my belt and disc sander. It was a little bit tricky working up and behind the miter saw station, but I managed. The final step of installing my system was to ensure the maximum airflow from my ports to the collector by sealing up any potential areas that air could leak. They may seem small and insignificant, but the various areas where you made connections to blast gates, other pipes, etc. all contribute to the problem of air leakage. Now granted, in most cases we're talking about 0.5 millimeter or less at connections, but think about it. Multiply that by the circumference of your pipe, then multiply that by the number of connections you made, each blast gate having a connection on both the front and back, remember, plus the fact that adjustable elbows can be a little leaky too. All in, I'm willing to bet that all these tiny leaks amount to the equivalent of a 4 to 5 inch port sitting open at all times. The solution, thankfully, is quite simple: tape and caulk. The duct taping not only adds strength to the connections, hence why I taped some of my lesser supported connections earlier on, but the tape also makes them airtight. Taping is quite an easy task, but admittedly less fun than putting the ducting up, which I found super fun. I recommend cutting a bunch of strips of tape to the correct length to go around the pipe diameter you're currently working on, and then do a bunch of seams all at once, rather than trying to measure from the roll while up on the ladder. I also found it a bit difficult to get it around some of the ceiling ductwork that I had securely tied into the ceiling, requiring me to temporarily loosen some of those brackets to do the taping. Taping works well on areas where you have room for the tape to sit flat on each side of the joint, but if you need to seal a joint such as a blast gate where you don't have room for the tape on both sides of the joint, that's where caulk comes in. I had never used the type of caulk that Oneida includes before. It's a type of clear silicone caulk that uses acetic acid to help it cure. If you do any cooking, that acid may sound familiar as it's the primary acid in vinegar, so this caulk literally smelled like white vinegar as it cured. I'd never come across that before, so it caught me a little off guard at first, but I'd rather smell vinegar than a strong, volatile chemical smell. With all the pipe ran, blast gates installed, and joints sealed, I fired up my dust collector to use for real for the first time to plane some small cedar boards. In the past, if I had to use my planer, I do it out in my driveway and do my best to sweep up the many chips afterwards. Well, I'm literally right next to the planer and had forgot to put my mask on, yet I couldn't sense any obvious fine dust in the air, and I couldn't see any larger chips flying out of the planer either. Game changing. This will likely be the end of my dust collection saga for now, but if I ever automate my dust collection or expand my system using the area we've capped off for now, I'll be sure to share either here or over on Instagram. If you'd like to grab the collection of bracket files for an installation of your own, check out a link to my website down in the description. Finally, thank you again to Oneida for sending me all the parts to make my dust collection dreams a reality, and to show you all how I did it. If you'd like Oneida to help you design your system, there's a link in the description for that as well. Until next time, cheers! So this is my second dust collection video, and I just realized that I have yet to make the old "this dust collector sucks" joke, and I don't want to get canceled by the other woodworkers on YouTube, so this dust collector sucks. Bye!